All right, so today's topic, AEC and the Q-SYS conferencing system. So today we're going to talk about, some of the major topics in this presentation are going to be, we're going to go over first the conference technology, the terminology that we use during conferencing. We're going to talk about a little bit of the best practices of applying AEC and then also how to apply and calibrate AEC in the Q-SYS environment. So we'll go ahead and get started on this. So one of the first terms, conferencing systems in general allow for participants in one room to communicate with participants in another room, whether that be with VoIP or POTS or soft codec USB bridging. It could be from dedicated hardware-based form factors as well. Like a codec, hardware-based codec, video codec, or things like that. So the reason we use that is that we want the ability for one room with open microphones and speakers, essentially allow speaker phones in each room to be able to communicate effectively without issues. So to do that, we need to talk about some of the terminologies that go along with it. I'm going to talk about the term far in. So the far in this situation is going to be the people on the, what is the far end? It's the room or the rooms that receive the near end signal. So if I'm in this room having a conference call, I am the near end and you folks on the other end of this are the far end. The far end will participate in a conference with me. And so both are my room, my near end and far end is different than someone else's that's on the call in another room there. I'm transmitting my audio to the other end. So all of you are on the far end with my near end call. And then, of course, we're talking about near end. This is where audio passes from the people on the other end of the call back into the room. And this near end audio is going to consist of local signals in the room. So any program audio or things like that coming out of the loudspeakers. But it's also going to be the audio coming from the far end. So the near end, so problem there is when we get audio back into the room from the far end into the near end, it's going to bounce around the room and it's going to go into the microphone. And so that's when we need acoustic echo cancellation. So as you can imagine, the idea is the microphone is not an intelligent device. It just measures sound pressure waves, right? So when sound waves hit that or sound pressure hits a microphone, it can't determine the difference between if that's coming out of the loudspeakers from the far end or if it's the voices in the room that's going to be doing it. So that's when acoustic echo cancellation comes into effect. So in acoustic echo cancellation, we apply it a reference to be able to differentiate between what should be subtracted and what should be left there. Problem is, it's not just a simple equation, right? Because the sound doesn't just come straight from the loudspeaker directly into the mic. As you can kind of see in this illustration, it kind of bounces around off the table, off the wall, off the back of someone's head, whatever the case may be. So what we do in here is we come back here and we determine what's going to be coming out of the loudspeakers, and we create a reference of anything that that's coming out of the loudspeakers and that we don't want to go to the far end, which would be everything, right? Because the audio from the callers on the far end is going to come out of that speaker. And if it goes into the mic and goes back to them, that's going to be perceived as echo. So the signals from the speakers go all around the room, and that's why we have to create a reference, and we apply that to the signal and do. Now at the microphone, what we're going to see is we're going to have the direct signal that comes straight from there. And then you're going to have a first reflection and a second reflection. And so you can see this becomes a more and more complex problem because they're slightly shifted from each other and they're smaller and they're in varying amplitude. So it's not like we can just immediately cancel this with a 180-degree out of phase signal. We actually have to do this over a given amount of time while that's doing. It's very complex. But in the AEC algorithm, it receives this. It receives the signal from the mic, and then these signals are compared to the AEC reference that we provide. So, and you can see in this drawing, here we've got the different reflections at the microphone. But when we apply, the signal we want to remove is the actual what is in the reference there. We're going to apply this reference, and it's going to start lining up, and this is when the adaptive filter will go to work. So the adaptive filter scales and time shifts the reference signal to eliminate echo. So it'll phase shift it, get it to where it needs to be, and then it will cancel and eliminate that echo. Now, then the task is it needs to continue on, right? So it's going to now scale it, time shift it out a few more milliseconds, and it's going to now cancel the second or the first reflection. And then we would go down and do the same thing when we get to the third and the next reflection. Now, in a perfect world, reflections at the mic would match exactly, right? And there would only be 2 reflections, but there's not. There's going to be 3, 4, and depending on the reflectivity of the room, it's going to be even get more complex than that, right? So unfortunately, that's not the case that we can just match these up with, 1, 2, 3 references, apply them, and they're done, because it's always going to be changing. Depends on, so many different factors of the room. So the algorithm has to be much smarter than just this. So we scale, we time shift that second reflection, but like I was saying, then we move on. So parts of the AEC algorithm here. We've got the incoming signal goes into the AEC reference. Your incoming signal coming in will go into the reference itself. And then it's sent to the adaptive algorithm. The noise reduction filter, is also inside this. The algorithm will set up an adaptive filter, which will sum together down here with the microphone's actual audio coming in as well. And so through that, the error signal, whatever is not canceled, is sent to the adaptive algorithm, so it can work to reduce this echo as much as possible before sending it back to the far end. And the idea is that the microphone would just come straight through and go in, but it runs through this summer, and the summer, it's the out of phase signal, cancels it, and then we use this little bit of nonlinear processing on the end to clean up anything that didn't get through. So some terminology, like we said back at the very beginning, the room with the AEC to cancel, the near end is the room with the AEC to cancel echo going to the other parties on the call. The far end is the room on the conference with the near end. And that could be multiple far ends, right? But the AEC in the near room cancels all of the echo for the far end as well. The AEC reference, the signal we wish for the AEC algorithm to remove is on the incoming mic. So that's what the reference is. And then convergence is adaptation of the filter to reach successful echo cancellation, right? So that's what's happening. When we converge the two, we're adapting that filter to effectively cancel the echo. Now the latency is how long it takes to do this, right? So it takes a while, and we have to have a little bit of look ahead time. So our old algorithm needed about 13 milliseconds. Today's algorithms, as you can see there on the 8 flex, 4 nano, the NV32, and the Core 110, all need, 32 milliseconds from input to the conference output, and 21.4 milliseconds to the reinforcement. Oh, let me just stop here and answer a few questions. Will this be recorded and sent out via email? Yes. We will get about 1 week after this session, you will get a copy of this. And are you on version 10? Well, I'm not on version 10 yet because I'm at my desk. So, but no, version 10 is out there. And so whether or not the reinforcement out should, okay, we'll actually cover whether or not to use the reinforcement outputs, and I'll give you some guidance on that before we're done. So I'll leave that one in. Let's get back to what we were talking about here with latency. So in latency, takes a little while to do this. You'll notice that we have input to conference outputs. And the reason here, we'll touch on it just a little bit, input to the reinforcement output is 21.4. It's a little bit less, and the reason is essentially the reinforcement outputs that are integrated into the block allow run through most of the processing that happens except the last little bit of non-linear processing. And it kind of does that mix minus for you. But we'll talk about some guidelines of when to use that and when not to use that. Tail length is the latest possible reflection that can be canceled. So everything we're talking about is in time, how long it reflects. Now, the effect, tail length in Q-SYS can be adjusted from 100, 200, 300, or 400 milliseconds. Now, the industry standard today for echo canceling is around 200 milliseconds. And as far as I know, in this Q-SYS platform is the only one that allows this right now. And there could be other ones that have come out since recently, but that allows us to shift from 200 milliseconds to 100 to 300 to 400. When do you actually change that? So the tail length can be changed, should be left at 200 for most normal rooms. But if you have a really highly reflective room or a larger space, and maybe it's a 3 walls of glass or a concave ceiling over a hard table or something like that, you may want to move it up to 300. Or if you're continuing to get reflections, you should go to 400 milliseconds. Now, those costs, those have a cost associated with them, in that if you have a previous Core 110, it does 16 channels of echo canceling. That's at 200 milliseconds. When you go to 400, you only end up with 8 channels. Now, on the 100 milliseconds, it does give you, on a core rated for 16 channels of echo canceling, it will have the ability to do 24 instances of AEC, but a 100 millisecond room is going to be very well acoustic treated. It's going to have microphones that are near people's mouths, maybe cardioid elements, things like that. So that's a little introduction to tail length and what it does for you. But essentially, what this does is effectively adjust the length of the adaptive FIR filter that's in the process. So the longer the tail length, the more DSP resources are. So, all right. So echo reference to microphone level ratio. So the difference in the level between the reference signal and the resulting signal at the microphone. So it's going to be the RMLR ratio. And so this is expressed in -20 to 10 dB. So it's a -30 dB swing there. So the mic is picking up the signal and sending it to the algorithm at -30 dB down. The reference signal is receiving its signal at -20 dB. The signal in the mic is 10 dB lower than the reference. For best performance, the goal is to adjust that control until your RMLR is at 0 dB. The echo return loss enhancement, the ERLE, is the difference between the level before and after the AEC processing. So this value indicates how much in dB of the far end echo is arriving at the near end microphone is being attenuated by the adaptive filter once it's converged. The ERLE meter is used to indicate how effective the AEC is in terms of suppressing the acoustic echo. A reading below 10 dB during just the far end talking only will indicate that the room's tail length may be longer than the AEC's tail prop. So if you're just getting reflections and you're getting some reflections back in, don't immediately go to to a higher tail length. There are some other adjustments you can make in there with the nonlinear processing, all of that. But do know that if you're seeing consistently when you're having the far end conference talk into the space, if that is significantly, if the ERLE meter is consistently below 10 dB, then you probably do need to up your tail. So readings near 20 dB and above indicate that the AEC is properly adjusted. So the next one, residual echo suppression. So we've got a few more terminology to go over here. So residual echo suppression is the same as nonlinear processing. It removes any error signal after the AEC algorithm is converged to move through. So we talk about voice lift. In large rooms where near-end microphones are sent to the near end. So this would be where we have a room where we're lifting, maybe I'm an instructor at the front of a training room or a multi-purpose room, and I just need to lift my voice to the back of the room. Mix minus is going to be larger rooms where there are a number of distinct speaker circuits, and for voice, and we use those for voice lift purposes, but we're strategically mixing a reference for each microphone in the space, because not only now what it isn't just the far end audio and the local program audio that's coming out of the speakers going in the mics, but it's other microphones in the room. So that's where that becomes important. So when we look at this here for our path to the far end is we have local microphones, we go through the AEC, and then we do some auto mixing. Now, I prefer a gating automatic mic mixer. But if you like to use a gain sharing, we say 8 mics and below is where you should target using a gain sharing auto mic mixer. And we'll talk a little bit more about that. But the path to the near end is that the audio comes in from the near end, whether that's VoIP, whether that's USB, or coming in from codec, or whatever the case may be, and it goes out through a mixer where it gets mixed with local sources, and then it goes out of your loudspeakers. And there, you'll see that we have our reference being pulled off right here before it goes out to the port. Now, this is very simplified. You're probably going to have things in there like, you may have some volume controls. All right, I'll come back to some of these questions in just a moment. Let's move on. All right. So best practice is to apply any processing after you go through the AEC. You certainly can. There are situations, but best practice says, to come in to put any filtering, parametric equalizer, compressor, anything like that, you should try to target that after the AEC. There are some situations where you may have a beamforming ceiling mic or something, or a microphone that's getting a lot of low end rumble it's causing trouble for the acoustic echo canceller. And you can certainly move some EQ prior to that, but best practice is to do that. Also, privacy muting should happen on the outboard side here. So after the gating mic mixer, you can put a mute in here or mute the output of the gating mixer. But that's where you should do your privacy. It's best to not mute microphones before they come in the echo canceller. We want them to be able to hear what's going on in the room, so they don't have to reconverge. But if you do have to, in some cases, it is acceptable to apply a EQ ahead of the AEC. Never place dynamics or nonlinear objects ahead of the AEC. And what you've got here, so in this case, it'd be fine to put a high pass filter or a parametric or a low pass if need be before it. But what you don't want is any dynamic or any nonlinear objects, compressors and things like that. So, and we recommend unity gain throughout the signal. If required, place user transmit gain ahead of the transmit block. Don't put any kind of gain controls before the AEC or before the gating mic mixer or anything. And then set that range to avoid any kind of clipping. Remember, don't give the user enough control to break the system. Also, we want to make sure when we're talking unity gain, the input meters in Q-SYS are all in dB full scale. So you're not looking for 0 there. You're looking for a -20 dB full scale, which clipping in dBFS happens at 0. So we want to be 20 dB. The most important factor in a successful AEC by far is for sure to have the AEC, the correct reference signal created. With no voice lift, the adage would be what goes to the loudspeakers goes to the reference. So that would be all of the far end product, the program sources, especially if you're routing them to the far end. But you never want to put a microphone into its own reference. And I have to admit, when I was new to conferencing, I'd be like, oh, well, I want to make sure there's no echo, and I would add those to it. So not something you want to do. The next thing to think about is place your user gain controls. You can place your user gain controls ahead of the mixer if you would like to on the near end, because you want some, there's two schools of thoughts on here, and we can certainly go back and forth. Sometimes it's best to just have one combined volume that's, the far end audio and the program source and all of that, if that makes sense. Depending on the complexity you want to give to your users. But if you are going to put, if you have one gain control out here, you want to make sure your reference is on the outboard side of that. But typically we see a little bit more where people will actually give a program gain volume and then maybe a call gain volume when they're in a call. So kind of your choice how you want to do that. But just know, you need to provide different volume levels in user controls. Another good rule of thumb there is never give a volume control to someone that to a sound they can't hear, right? So you never want to give the user a control to turn up the audio going to the far end. If the far end can't hear, it's their volume. Just a good rule of thumb on that. So let's go through an easy process to set up AEC process. So the first thing we're going to want to do is we're going to set all of our mics to a nominal level. So we're going to make sure that they're coming in around -20 dB full scale. And yes, that applies to whether that's coming in AES 67, Dante, whatever the case may be. The system should be calibrated to send a nominal level with no adjustments in the Q-SYS if possible. Now, you can use some digital gain and preamp gain if you need to after the fact. But the idea is everything comes in at -20. And then what we do is we're going to check the microphone signal to noise ratio. If the signal to noise ratio is greater than 15 dB, or is less than 15 dB, intelligibility standards in the room will not be met. Noise reduction and the noise reduction in the AEC algorithm can't deal with that. So the idea here is that if the noise floor, in this example drawing, the noise floor is at -42, and this is acceptable because between -42 and -20, we have 18 dB, right, of signal to noise ratio. So the noise floor is at -42, and the signal when we're talking into the mic is there. So it is greater than 15 dB, so we will meet the standards there. Now, so once you get that set properly, once you set that, then the next thing you want to do is make a test, or you're going to want to set your amplifiers to a minimum level, or set the output block's max RMS gain to -40 dB if there's no controls on the amp. So you'll use the preamp analog gain to bring all of the program sources and inputs to an input level of -20 dB full source. Leave the program sources at unity gain throughout the signal chain. And with a calibrated program source, you're going to put a calibrated source in. You want to bring the output in the room. So you can use, a simple DB app or something like that, a little simple RTA app on your phone or something. But basically, with that reference signal applied, you want there to be about 70 dB of signal coming out of the loudspeakers. The reason being the human voice typically is around 65, and people in conferences and conference calls want to hear that voice just a little bit more prominent than if they were speaking in the room. The next thing is make a test call. So we're going to adjust the far end's gain to a nominal level to make sure that it reaches negative. When the far end audio comes in, we're making the test call. We're going to adjust that level, make sure that it's -20 dB full scale. With the listener at the far end, someone listening on the far end, then we can start tuning in the AEC. Noise reduction enable and level. Noise reduction is only going to get rid of steady state noise. So you'll see the text down here in the bottom down here. And what that does is it's going to reduce the noise, of the projector fan, of maybe a network, anything that's a common steady state noise. Bob the loud talker in the room, in the office next to the conference room, it isn't going to get rid of Bob the loud talker unless his loud talking sounds like a fan that's running. So that's just one thing to look at, be aware of. Now, the next control that we're going to talk about is the RMLR meter. So this is one of the easiest ones in the whole thing to set up. So when the bar is green, when it goes above this level, when you're applying too much reference to the signal, it's going to go yellow and then up to red. And if there's not enough signal, it's going to go yellow down to red. So the idea is you're looking for a zero signal right here. Now, the adaptive filter up at the top right here, what this does is if for some reason you have microphones that you need to mute your microphones before the echo canceling algorithm, you can certainly do that. What the adaptive filter does is it holds the convergence below the threshold before when the mics are muted, so that it takes less time for the algorithm to reconverge after that. And the way you set that up is you look at the noise floor of the room, and if the noise floor, I think on the previous slide was negative 42 dB, you're going to want to start that adaptive filter around negative 42, negative 45, so that it's kind of simulating that noise floor. Same thing for the reference and the mic. Next thing we're going to do is the residual echo suppression and the enable. Obviously, the enable button turns on this residual echo suppression. And this is where, you know, hey, I'm getting a little bit of reflections and I'm getting a little bit back from the far end. I can use this to adjust and get rid of some of those artifacts signal if you're still hearing it. So it's kind of, you know, but remember, the more you use of this, the closer you're going to get. You're going to get further away from two-way communication and get closer to walkie-talkie. So if you get that really up in the 75% and above, you're going to start reaching where only one end is able to talk. So be cautious. And then the next thing you do is you'll repeat step 4 for each of your conferencing types. So that's one of the things that's important. So a lot of times, you know, we'll see people that will set something up and they'll set up a conference system, and I even used to be guilty of it too. I would set it up for, well, the POTS line is the dirtiest signal. So if it sounds good on that, it should sound great on everything else. But even your other sources, your VoIP, your USB, you still need to go through that signal chain, make sure the input gain is set properly and all that. And then test it, if possible, if you can get calls on all three. If that's a scenario that's going to happen, you need to make sure that you do that. If you have a hard video codec and maybe some soft conversations going on, same, you want to be able to do that. But what happens if we still have the echo after this is all, after we've set everything up? One of the things you can do is go through and mute your microphones to verify that it really is echo and not just a direct coupling, meaning you routed the mic back into itself by chance. You know, some of our sample designs show 2 different mixers, one for the signal going to the far end and another mixer going to the near end loudspeakers. That's one way to kind of avoid rerouting the mics to there, because you don't need the local microphones to go out the loudspeakers, so you can never build your reference to include that. So that's a good safeguard. So you want to make sure that your signals aren't misrouted or looped somewhere where they need to be. And if you still have echo there, then you need to go through and start muting all your inputs one at a time until you identify what the misrouted source is. So just a little bit of thing. Now, I talked about earlier, what if there is still significant echo? Check the tailwind. By default, it should be at 200 milliseconds. And so, you know, if it's at 200 milliseconds, you know, you're not going to just, like I said, don't immediately just go to 300 and 400 milliseconds. It's only very large and reflective rooms that require it. You want to go back and you want to use some of that nonlinear processing, and then start thinking about maybe ways to reduce some of the reflectivity too. So I'm going to pull down some of the questions I have here, and we'll go back to it. So there's a question here from anonymous attendee. He or she seems to attend a lot of these. So whether or not the reinforcement outputs probably should be used on the AEC floor. So this topic comes up a lot. And there's some people, you know, one of the things I like to say is that doing DSP work is, or any kind of programming in a way, is like, is the same, is like artwork, right? So if I tell everybody here to draw, you know, a tree, they're not all going to draw an oak tree. But if someone draws a maple and an oak and a birch and whatever the case may be, they're all correct, right? As long as they've all drawn a tree. So, you know, some people will say, I never use the reinforcement outputs. I always bring my any mics that need to be lifted around that. So I actually talked to the person that, the developer person that wrote the algorithm, and his definition of when to use the reinforcement outputs is if the microphone element is never going to be in the path of the loudspeakers. So I'm an instructor at the front of a training room, and the last row of speakers in the room is where I'm lifting my mic to, because it's kind of a deep space. That's a good place to really use that. If you want to do everything and bring it around, you certainly can. So it's your choice. I say if you have a situation where the micro, but if you've got a handheld mic that's going around the room, that's going to be a little more challenging to kind of figure out how that happens. So that's kind of the rule of thumb. If the microphone element is not going to be in the direct path of the loudspeakers, you can certainly is when the reinforcement outputs are intended to be used. But if you're on a stage and there's a lot of audio coming at the mic and around the mic, that wouldn't be. All right, the next one we have, even with the D10 Q-SYS, is there any difference in the AEC? I don't have that right off the top of my hand. I'll have to look that one up. I'm sure it's in the help file. We'll take you take a quick look in there. Just type up Q-SYS help file online, and it should bring up that and look up AEC. Kyle Benson asks, would a single AEC block with 8 inputs and 1 reference consume the same DSP resources as 8 AEC blocks, each with a single input and a reference? Now, in previous versions of Q-SYS Designer, I know that I ran into, this was a couple of years back, someone had a Core 110, which should support 16 channels of AEC at 200 milliseconds. And they had each AEC block was in single channel. And he sent me the file and said, I can't get this to compile. It won't compile. This is actually when I ended up talking to the developer, the guy that wrote the algorithm, the AEC algorithm, because I'm like, what's going on in this file? If there's 16 channels, it's a Core 110. And when I got in touch with him at the time, back then, what he said was we process blocks of AEC in groups of 4. So the person had built the design to just make it really clean with one block, one AEC channel for each one, and it wouldn't compile. We moved it to 4 channel AEC blocks and everything worked great. So, but I was giving this lecture a few weeks back and said, well, let me show you this. And I did 16 single channel blocks, and it did combine. So it doesn't use any more resources, but if for some reason you do get a won't compile, you may want to take your individual AEC blocks and put them into blocks and folders. Hopefully that helps on that. In 200 milliseconds the best default starting block to use when programming a file with AEC from scratch? Can it easily be adjusted to 100 or 400 on the fly, or must the block be replaced if tweaks are needed? So that's a great question, Alfred. The question there is so if you do have to go offline and change the properties and then re-push the file. So if you look at other manufacturers around the industry that do AEC, all of those AEC algorithms, I don't know the specs exactly, but they're somewhere in that 200 range. So I would not start at 100 milliseconds. I would start with 200 milliseconds. And like I said, if it's a well-treated room, and you don't need a lot of and it's working really well, you may want to experiment to go into 100. But if it's working at 200 and you have enough channels to do what you need to do, AEC channels, then I would leave it at that. If you're getting reflections and you have tried nonlinear processing and post AEC adjustments, and you still can't get it out, and the meter indications are showing that you should do that, then by all means you should. Then you can move up to 300, 400. Daniel asked, did you mean that the reference should be after the user gain control? Yes. If you do put user gain controls in, you want the reference to be after that. If you're going to put your gain controls after the mixer and just have a single gain control. The idea is because as you turn the volume up for what's going on in the room, you want the amount of reference to go up as well too. So good question on that. Chris Cummings has a question. I have a system, in my system, I have a Sennheiser TCC2 coming into a core, and all the audio ports are going out to QSC network amplifiers separate to. There is no boundary clock. Do I need to worry about creating AC processing to that time misalignment, or is time alignment achieved internal in the core's all processing? Yeah, I would think once the Dante hits the core, there's there is a little bit of delay in there, but we operate, we have been operating for multiple years with mics coming in from AES 67, coming in from Dante, and so that little bit of latency added on to the latency in there is there. But we do have a planning clocking domains deep dive webinar. I think we'll be giving one of those in July, Chris. So if you're if you want to make sure that you've got your clocks, your boundary clocks set up right and how to move that. I noticed in here, you're using a Core 510 with a card. So, you know, one of the benefits of software-based Dante is that the core itself can be the boundary clock. So anyways, I recommend tuning in for that. But yeah, you shouldn't have any serious time alignment, even with whether you're using a hardware-based Dante solution or a software-based Dante. Is there an advantage to use separate AEC blocks based on microphone type? Yeah, there actually is. And you can do a blend of that. Now, we don't publish a chart in the help file. You know, we say Core 110 will do 24 channels at 100 milliseconds, 16 at 200, whatever. But let's say that I had a couple of table mics in a conference room, but then I also had, you know, a couple of lavalier mics, or I had a couple of, you know, stationary mics that are going to be close to people's mouth. I might want to put, you know, those in one block. But each AEC channel is going to treat each mic differently, but you may want to build different signal paths. And so that's where it might make sense to say, hey, these two mic channels are going to be 100 milliseconds, and I'm going to treat them different in a different EQ path. And then maybe the table mics have to be on 200 milliseconds. Is there an article published online with ERL and ERLA? I believe there is some documentation. There's also, this comes from a quantum series of training, so there's also some options and things out there on the actual target levels. But the idea there is to use the meters in the in the actual algorithm and follow the guidelines involved. If you have one zone of speakers and multiple wireless mics in a system that are reinforced, do you do an AEC mix minus to route each mic to all other mics references? Well, if you have only one zone of speakers, really mix minus is where you have multiple zones of speakers, and depending on where mics are located in reference. You know, for instance, if I'm doing mix minus, that means that the loudspeakers over my head aren't going to reproduce my microphone sound. And the speakers 10 feet away from me maybe get 6 dB down of my signal. And the speakers 15 feet away from me on a separate speaker zone would get, you know, it's 3 dB down from my signal. So there are some creative ways I've seen people do where, you know, they'll, if the loudspeakers in the room are primarily being used just for conferencing or for voice lift, they might, and you only have one amplifier channel, you can tap the ones at the front down a little bit more and tap the ones at the back of the room up. But, you know, now we're getting into hypotheticals and not preferred case scenarios. What's the best place to pull the reference signal from? It's its own out of the matrix mixer or wire tag from the speaker output of the mixer. I prefer to build my own reference and treat it separately, but essentially that reference is built from whatever is going to the loudspeakers. And obviously we showed a very basic conference path. Very seldom is that actually that complex of a path, or is it that simple of a path? So I typically build my own reference and I say whatever is going to the loudspeakers goes to there. So it's a matter of whichever one works for you. I would say for me, my best practice is to do it separately. But if it's a basic system, you can certainly have it tied, right? When using the Shure MXA 920, do you recommend using the mix out or the individual channel out? You know, if you asked me this question, David, several years ago, I would say that there were some challenges with the mix out, just because, you know, it's bringing a lot in. So I think that we have systems that operate well with both form factors, whether you're using the mixed channel out. Also, the 920 is, you know, a little bit better processing than its predecessor and things like that. Obviously, I'm a fan of, you know, if you have an AEC channel for every mic channel that's being brought into the system, that works really good. So I would experiment with both, but I know that we have lots of deployments, and even here in our new experience center, we're using the MXA 920s and we're using a single in from those, so and it's working well. So that should work great. Is it best practice to mix all mics down to one channel prior to the AEC reference, or would you send each mic to the other mics? So the only time that you're going to send other mics to the mics references is if you're doing that mix minus type scenario, Spencer. And in a way, when you use the reinforcement outputs, it's in a way doing a little bit of that for you as well. So the best thing, you don't need to mix, you can mix all the mics down. I would bring each mic should come through the channel, its own individual AEC channel, but that's kind of what it should. I think that what Andrew was at, and Aaron's popping in. I think what Andrew was after is there, if there are 3 wireless mics, does one mic get the reference that includes mic 2, 3, and mic 2 gets a reference of 1 and 3, and so on, sort of. And that might be, that might be the case. If you've got 3 lavalier mics in a room, that's where you may want to apply some of their reference to each other because someone may be at a different part of the room in that. So you certainly could apply it. Anyway, well, wished I would have brought a bottle of water in before this went up here. So we certainly do appreciate everybody taking the time today. We do have some other resources out there and available for you. You will get in the coming couple days, you'll get a link to this in the next week or so. I know a lot of our marketing folks are still a little bit, their biggest event of the year was last week. So they're still recovering a little bit. So maybe into next week before we get a follow-up with this. You'll also get a PDF of this PowerPoint presentation. So if you want to use that as a reference. And then we also send out what we call the placemat. So it's an 11 by 17 that kind of walks through, step by step. It can be printed on 11 by 17, have your technicians fold it up, put it in their bag, and they've got a constant resource. Anyways, give you guys and gals 15 minutes of your time back today. And we really appreciate you attending and look forward to the upcoming ones next month, later this month, we've got, I think, Designing with ND series. So, that comes into play. And then next, we're looking for that clocking domain and things like that. So is there a place that has placemats to pull from? You can contact your regional sales rep team. They can get you one, or I don't know if I don't know if it's readily available on any of the sites, but you'll definitely get it in the next week as well too, Mark. So, but also reach out to you there. Thanks for the talk. It's been appreciative. All right. All right, Aaron's got a thing here. It says, on a call once a couple years ago, Cookie explained to me the different scenarios when you use the reinforcement outputs versus pulling a dry signal before the AC. Well, that's why I say I'd heard so many different people, and Aaron's a coworker here as well. I've heard so many different people have different stories like, oh, I never use the reinforcement outputs or don't use them or do this. And that's why the one opportunity I had when I had the person that wrote the algorithm on the phone, like, why do we have these? And some people say don't use them, some people do. And he explained the purpose of, like I said, if I'm standing on a stage and I'm lifting my mic, or I'm standing at the front of a room and I'm lifting my mic to the back of the room, that's a perfect time to do it. But if if I've got loudspeakers on either side, potential for that audio to be in the microphone element path, then we want it. So that's kind of the rule of thumb I use. So anyways, well, have a great day, everybody, and we'll talk to you later. Thank you.